But I found that this problem is much more exciting, so I decided to go through each step that was scribbled, all with equations in this board. So the board is in front of you. So this is the board that had scribbled equations, all full of complex numbers. I'll be describing you what is a complex number, but first of all, let's have a look at this. Sin x is equal to pi. So now let's begin. Let's say x is equal to theta. In this equation, so e to the power I theta is equal to cos theta plus I sin theta. And e to the power minus I theta is equal to cos theta minus I sin theta. So this is a complex representation which can be found by derivative as well. So this is truly a wonderful idea. The statement that I have written in the right hand side of the screen is the most wonderful idea, because it says that you can derive e to the power I theta is equal to cos theta plus I sin theta by using a derivation rule, where e is an exponential function and I is a complex number. So let's see what we can do more. So now please pause the video and try to find out a complex representation of sin x in terms of e to the power I theta. You can use the following rules, which was shown to you in the previous slide. So the rules are this. So e to the power I theta is equal to cos theta plus I sin theta, one rule, and e to the power minus I theta is equal to cos theta minus I sin theta is another rule. So you can use these two rules to find sin theta in terms of e to the power I theta. So please pause the video and try this out. Okay, so I hope that you have tried this out. Now let's do some algebraic calculations, okay? So let's see. As we know that e to the power I theta is equal to cos theta plus I sin theta, and e to the power minus I theta is equal to cos theta minus I sin theta. I have already said that this term, for now, let us assume that e to the power I theta is equal to cos theta plus I sin theta, but in another video I'll be preparing some slides which shows you how we can derive this form. So e to the power I theta is equal to cos theta plus I sin theta. So how can you derive this? By using derivation. So for now, let's say that e to the power I theta is cos theta plus I sin theta. So let's do some algebraic calculations and let's subtract e to the power minus I theta with e to the power I theta. So we get 2I sin theta, right? So you can do some calculations out there and you will get 2I sin theta. So we have got this sin theta term, but we have got extra term which is 2I. Now if we divide both sides by 2I, in e to the power I theta minus e to the power minus I theta is equal to 2I sin theta by 2I, and in the both sides if we divide it by 2I, we'll get this term, right? So dividing it by 2I, so we'll get this one. So if x is equal to theta, I represented theta as x, so I can write x as theta and theta as x. That doesn't matter at all. So sin theta is equal to e to the power ix minus e to the power minus ix by 2I. So now that means we have found this term. So we have found the main conclusion of this video, which is sin x is equal to e to the power ix minus e to the power minus ix by 2I, which is the first step towards the solution of sin x is equal to pi. So now let's do another step. Okay. So let's see. Just now my brain clicked and it said that wait a sec. Let us be familiar with derivation, complex numbers, and the derivation of e to the power I theta is equal to cos theta plus I sin theta. Hmm. So do you know what that mean? So this was quite fun, right? Okay. So let's wrap up the second step of this solution after a couple of videos. But the next video will mainly be based on the derivation and some history of e to the power I theta. So you might be thinking why I'm doing this kinds of complex number stuff in sine x is equal to pi, because if you like somehow if you use a calculator, a scientific calculator, and find the value of x, then the arc of sine of pi will be error. So you'll get an error sign out in the calculator. So this is some stuff that I'll be speaking of in the next video. But for now, we will be back. So we'll be back in another video. So have a good luck and have a good day.